Hello, this is Sadhvi. The topic of our discussion in this video tutorial is a non-homogeneous differential equation and method of undetermined coefficient. This is the part 1 of our videos on this topic. What is a non-homogeneous differential equation? A differential equation is called a non-homogeneous if it has a forcing term. The forcing term is a term which is only depend on the independent variable. In this case, is depend on t, and it does not multiply to the dependent variable, or it depend on the dependent variable. So, for example, in this case, g of t should not have multiply by any y or y square or any type of function of y. In this particular case, since this differential equation is second order, so we will call this is a second order non-homogeneous differential equation. So let me give you a few examples. For example, 2y double prime plus 3y prime plus 6y is equal to 3e to the power 2b. This is a non-homogeneous differential equation because here is a forcing term. This forcing term does not depend on the dependent variable y, it's only depend on the independent variable t. One more example, y double prime plus 3t y prime plus 8y is equal to 2 sine of 2t. Again, this is a forcing term which is a g of t. So since this is a non-zero, that means this is the reason we call this differential equation non-homogeneously, because it has a forcing term which is not equal to 0. To solve non-homogeneously differential equation, we use the method of undetermined coefficient. So let me first give you the example of what is the method of undetermined coefficient. So in the method of undetermined coefficient, first what we do is we try to find the particular solution of the differential equation. So as you can see, the particular solution of or any solution of this differential equation must have some sort of an exponential, because the exponential derivatives, first derivatives, second derivatives, they all should be involved here so that you can get the exponential in the forcing term. So y should be a sum function of e. And here we're gonna first assume y must be a function, some constant time, the function of 2t, because the forcing term has this e to the power 2t form. So this will be our assumption. So we assume y of t is a solution. So this is our assumption, and here a is the constant, and we will try to determine this constant. How we will find this constant? Since we assume this is a solution, we will calculate the first derivative and second derivative and plug back into this equation. I'm going to call this equation number 1. So if I calculate the first derivative of this equation, I will get 2a e raised to power 2t, and if I calculate double prime of this equation, I will get 4 times a e raised to power 2t. Now I will basically plug everything into the equation number 1. If I do so, I will get 4a e raised to power 2t minus 3 times y prime, which is a 2a e raised to power 2t minus 4 times y. So y is a e raised to power 2t, and this is equal to 3e to the power 2t. Now you can see that why we choose such a solution, because e to the power 2t can be pulled out, say is in every term, So now this is a 4a, this is a minus 6a, and this is a minus 4a. This is equal to 3e to the power 2t. Because e to the power 2t is a common, it's a non-zero, so we can cancel this out, and this become 4 and 4 cancel, so it's minus 6a is equal to 3. So here we were able to determine the coefficient, which is equal to 3 divided by minus 6, which is nothing but it's a 1/2. So now, since we have our constant, so we will plug back that constant into the particular solution. So our solution is y of t is equal to minus 1/2 e to the power 2t. So this is a particular solution of this differential equation, is a particular solution. Particular solution is a solution which does not have any constant, you know. So this is a particular solution, and the method to find the particular solution of a non-homogeneous differential equation is called method of undetermined coefficient. Here I have some more examples. You can pause this video here and try to solve a particular solution of these non-homogeneous differential equation. Here I have one quiz problem for you to practice. Please pause the video again and try to solve this problem. Here is our second quiz problem. You can pause the video for a minute and solve this problem and come back. Here I have one theorem which gives you the general solution of a non-homogeneous differential equation of second order. The solution is basically, first you will solve the differential equation, the homogeneous part of the differential equation, by assuming g of t is equal to 0. If you put g of t is equal to 0, or you make the forcing term is equal to 0 and solve a differential equation, that will give you a general solution. And then you find the particular solution of the whole equation, and then you add these two solutions. So it's a two-step problem. In step number 1, we have to find the general solution of a homogeneous differential equation. And in the second part, we will use the undetermined coefficient method to find the particular solution, and the sum of these two solutions will be the general solution. So here is the three-step process. So first we will solve the homogeneous differential equation, which we have done in our previous videos. Then we will solve the particular solution. We will find the particular solution by using the method of undetermined coefficient, and then we will basically add these two solutions. This will be the general solution of our differential equation. Let me give you an example of this whole process. So solution, in this example, we will basically solve this in 3 steps. In step number 1, we will solve the homogeneous part of this differential equation. Homogeneous part means when the forcing term is equal to 0, means we will consider that there is a no forcing term in this case. And we already know that we can find the auxiliary equation, or sometime we call it a characteristic equation, which is a r square minus 5 times r minus 2 is equal to 0. And then we can use the quadratic formula to find the root, minus b plus minus b square, which is a 25, minus 4ac, which is 4a, this is a 8, and divide by 2a, which is 1. Therefore r is equal to 5 plus minus, and the radical of 33 divided by 2. So means we get two solution, r1, which is a 5 plus radical 33, divided by 2, and 5 minus the radical of 33 divided by 2. So this give us a general solution. So y of c, I'm going to call it a complementary function also. They call it a complementary function, y of c. So it's a c1 e to the power the first root 5 plus radical 33 divided by 2 t plus c2 e raised to power 5 minus radical 33 divided by 2 t. So this is the complementary function, or in other words, this is the general solution of the homogeneous part of our differential equation. Now let's go to the step number 2. Step number 2 is where we will solve the non-homogeneous differential equation. It means we will basically find the particular solution of this whole non-homogeneous differential equation. As you can see, the particular solution of this differential equation will be form a time e raised to power 2t. The reason is that the forcing term has e to the power 2t term. So the particular solution must have e to the power 2t type term. So we will multiply a and we try to determine a. So again, if I calculate y prime, I get 2 e raised to power 2t and also a here, and y double prime will be 4a e to the power 2t. If I substitute here, I'm gonna get e to the power 2t common factor. I'm just doing some calculation a little faster, and I'm going to get 4a here minus 5 times this, which is a 10a, and minus 2a is equal to 3 e raised to power 2t. So 2t e to the power 2t cancel out, and this is basically negative 12 minus plus 4, which is a minus 8a is equal to 3. So a here is 3 divided by 8 with the negative sign. So this tells us the particular solution of this differential equation is minus 3 over 8 e raised to power 2t. So now we can go ahead and write the general solution. So the general solution, which will be the step number 3. So general solution is y of t, the sum of this solution and the sum of this solution. So it will be c1 e to the power 5 plus radical 33 divided by 2t plus c2 e raised to power 5 minus 33 divided by 2t plus the particular solution, which is basically negative, so minus 3 over 8 e raised to power 2t. So this is the general solution of this differential equation, which is the sum of complementary function and the particular solution of our differential equation. Okay, this is the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.